Hey guys, today we are kind of wrapping up our conics unit and we're figuring out how do I know what type of conic section I'm looking at if I'm not told it's a parabola, hyperbola, etc. So if you remember, when I am trying to form a conic section, all I'm doing is taking a plane, like a piece of paper, not an airplane, and I'm cutting into two cones that are stuck together. And so when I'm looking at it, these are all the possibilities. I can make an ellipse. Once I get it to a certain point, it's going to be a parabola, the hyperbolas that they're both, the two branches are going there. And then finally, we're going to get to the circle eventually. The two lines is actually a degenerate form of a conic that we're not talking about. Until finally we get back down to that ellipse, and then you're going to see a circle when it's parallel to the bases of the cones. Okay, so if you're looking on your foldable, this is actually on the back of the purple section. These are all the formulas you might need to know for conics. So this is the general form. This is something that we haven't really talked about yet, where you're looking at the whole thing all ugly that we're going to have to complete the square in order to get it into a standard form that I'm used to. Now you notice they use P on this. Oh, they use the letter P instead of the letter C like we've been using. It's the same thing. It means the same distance. They just like to use a different letter on it. Okay, so what we're trying to figure out though, if I was given a general form of a conic equation, how would I know what type of conic section it is? And you don't have to write this down. What we're looking at though is these are all examples of equations of circles. And so if I look at all of these equations, the one thing that stands out to me the most is, first of all, they all have an x squared and a y squared. And then I noticed that the coefficient here of both the x squared and the y squared are exactly the same number, and that's what makes it into a circle. Okay, whereas if I look at the ellipses, they both have the x squared and the y squareds in them. However, the numbers in front of that x squared and those y squareds are different. Now they're different, but they're both positive. If I had a hyperbola, that's the one that we had the minus sign in. So if I look here, again, I both have an x squared and a y squared, but now they're different numbers and one is positive and one is negative. So that's what's changing here. Whereas in a parabola, and you remember this equation that we looked at 10.3, is that there was only one squared term in it. So if I have both an x and a y, but only one of them is squared, that's a parabola. Okay, so if you look on the back of your pink section in your foldable, we have this awesome flow chart that helps me figure out how to identify a conic given that general form. So the first question you ask yourself, are both those variables squared? Do I have an x squared and a y squared? If I don't, then it's a parabola. If there's only one squared term, it's a parabola. If there's two squared terms, then we have to ask ourselves some more questions. So we look and see, is there a subtraction? Is there one positive squared value and one negative squared value? If yes, then that's a hyperbola. Remember, there's the minus sign in the hyperbola. If no, then we're going to look at the coefficients of those squared terms. If those squared terms have the same coefficient, like 2 and 2 or 4 and 4, then we have a circle. If they equal each other, it's a circle. And if they don't, then we have an ellipse. Okay, so let's look at some examples. We're going to identify the conic and then we're going to write it in standard form. So the first thing we want to do is figure out what kind of conic section am I looking at in the first place. So the first thing I look for is is there both an x squared and a y squared. So on this one, I have x squared and y squared. So cool. Then I look and I see, are they being subtracted? Yes, one is positive, one is negative. So that stops me on my flow chart and I know that this is going to be a hyperbola. One thing on your notes, I actually changed it and it needs to be changed again. It should say equals 12 on it. Okay, so now that I know what kind of a conic section it is, I'm going to go ahead and write it in standard form. And in order for me to write it in standard form, I have to complete the square. You're going to have to complete the square the number of times you see both a squared and a not squared term. So for this one, I'm only going to have to complete the square once because I only have an x squared and a 4x. I don't have a y squared and a y. There's still going to be something with y squared in there, but we don't have to worry about it right away. Okay, so my first order of business is I'm going to rearrange my equation so my squared and my not squared are together. Okay, and then that minus 16y squared is still going to stay over here, but I'm going to ignore it for a second. And again, this should be 12. And then I'm going to think about what would make this square be completed. So I take my b value, which is right here, -4, divide it by 2, and then I'm going to square that. So that gets me -2 squared is +4. If I add something to one side of the equation, I also have to add it to the other side of the equation. So I have to add 4 to that side. And again, this should factor into a perfect square. And that perfect square is going to have this as the other part of it, okay? Minus 16y squared, and that equals to 16. Okay, this still isn't in standard form though. Remember, in standard form for hyperbolas, parabolas, and I guess not parabolas, hyperbolas and ellipses, it says equals to 1. So I'm going to go ahead and make this equal to 1 by dividing each of my terms by that number over there. So my final answer for this one would be x minus 2 squared over 16 minus y squared, or y squared over 1 if it makes you feel better, equals 1. Okay, now that I have this, I could obviously find the important pieces like the center and slopes of the asymptotes, etc. Okay, so again, you have to complete the square in order to get into standard form. If I look at this guy, again, the first step that I had to do here was figure out what conic section this was representing. So I look and there's 2 squared terms, so I know it's not a parabola. The squareds aren't being subtracted, so it's not a hyperbola. I don't have a negative and a positive. And then so I look at the coefficients of my squared terms. They're different. If they're different, then that makes this an ellipse. Okay, and now to get that in that standard form of an ellipse, like that we saw in the formula chart in the purple section, we're going to go ahead and complete the square. So again, my goal is to first get my x's together. So I'd have 4x squared minus 24x. And then I get my y's together. Thankfully, there's only one y. Okay, so we're only going to have to complete the square once. Now the biggest problem here, when I'm completing this square, is that if you look, there's actually a number in front of my x squared. I can't get a perfect square out of that. I need to factor out a 4 from both of these terms. So I'm going to factor out that 4. And now this is going to be a lot easier for me to deal with. Okay, but I didn't change the value of anything else. I just factored out a 4. So now I'm going to look here, and I'm going to do that same process I did before. -6 over 2 squared gets me -3 squared, which gets me 9. So I'm going to add 9 into my equation. Now be careful. I didn't just add 9 to my equation. I can't just put plus 9 on the other side. When I looked here, I actually took 9 times 4 and added it to the equation. So I actually added 36 to my equation. Be careful. If you take anything out, you're multiplying it. Okay? So now I complete that square. So I'm going to factor it. This should be x minus 3 squared plus 9y squared equals to 36. Remember, your last step is to make sure that the other side equals to 1, especially if it's an ellipse, which it is, ellipse or hyperbola. 36, 36. And you're going to notice that these things cancel out. 4 over 36 cancels to be 1 over 9, which means that this is going to be over 4, and that equals to 1. Okay, now I'm in standard form. I could find my A, my B, I could find my focal length, I could graph my equation. Okay, so that's all I've got. Identifying conics, pretty straightforward. Just got to remember how to complete this square. Have a great evening.